everyone, welcome back to Chem Talk. Today's video will be an introduction to kinetics, where we'll cover some of the basic concepts in kinetics and learn how kinetics is used in radiocarbon dating. So let's talk about it. The study of kinetics relates to the rate at which a chemical reaction occurs. This reaction rate can be expressed as the change in concentration over time. Let's look at a graph to put these definitions into context. So on the x-axis of this graph, we have time, which is measured in seconds, and on the y-axis, we have the concentration of some gas, and the units for that is molarity. You may be given a graph like this and be asked to determine the average concentration over an interval of time. To do this, you would simply calculate the slope of the graph. So, for example, let's calculate the mean rate within the first 20 seconds. At 20 seconds, the concentration is 400 molarity. So we can do 400 m over 20 seconds to get 20 molarity per second as our rate. So in that example, we found a change in concentration over time for our reaction rate, which goes back to the definition we talked about earlier. Now let's think about something else. What is the effect of each reactant's concentration on the product's formation? We can figure this out by determining the order of each reactant. A reactant's order is that reactant's effect on the reaction rate. Take a look at this table to better understand this. From trial 1 to trial 2, A's concentration doubles, and the rate of formation of C also doubles, so A is a first-order reactant. From trial 3 to trial 1, B's concentration quadruples while the rate of formation of C increases by a factor of 16. So B is a second-order reactant. If you want a more in-depth explanation about how to find order, check out our video on rate law. But what I want you to take away right now is that reactant A and B impact the reaction rate differently, and we can see this by determining their orders. Now knowing some of these fundamental concepts, I think you're ready to try some practice problems. So up on the screen are some problems, and we have an answer key attached in the description box down below. So check your answers with that resource. Now let's dive into something a little more interesting. What are some of the cool ways in which kinetics is used today? Well, the basis for radiocarbon dating is kinetics. Radiocarbon dating is a process in which we figure out the amount of carbon, which is C14 in this case, remaining in a sample to determine its age. Over time, the concentration of C14 in an object decreases due to radioactive decay. We can express the rate at which this decay happens through kinetics. This reaction is a first-order reaction, and we kind of talked about order before, so hopefully you kind of understand what this means. And the reaction looks like this. I'm just going to write it out on the screen here. Okay, so as we wrap up this lesson, I want to do a quick recap of what we covered in today's video. Kinetics relates to the rate at which a chemical reaction occurs, and it can typically be expressed as change in concentration over time. We can look at graphs to determine average concentration over a certain interval of time. And in addition, each reactant affects the reaction rate differently. And we can examine how this effect plays out by order. We determine the order of each reactant from experimental data to figure out each reactant's effect on the reaction rate. And kinetics is super important in radiocarbon dating. It's used to measure the rate at which C14 decays in some sample. And that is all for today's video. Thanks so much for tuning in, and be sure to visit us at www.chemistrytalk.org to access more amazing chemistry lessons like this one. Bye!